Welcome, students. I'm delighted to see you all here today. As we embark on our journey into the fascinating world of linear algebra, I want you to imagine a realm where numbers dance in perfect harmony, creating patterns that unlock the secrets of artificial intelligence and machine learning. Today, we'll explore the mathematical foundations that power the cutting-edge technologies shaping our world. Let's begin by answering a fundamental question. What is linear algebra? At its core, linear algebra is a branch of mathematics that focuses on vectors, matrices, and linear systems. It's the language that computers use to understand and process complex data. Think of it as the alphabet and grammar of artificial intelligence. Without it, machines would be unable to learn, analyze, or make predictions. But why is linear algebra so crucial in AI and machine learning? Well, it's the bedrock upon which these technologies are built. When we represent data as matrices, calculate weights in neural networks, process images and videos, or even understand natural language, we're using linear algebra. It's the invisible force that helps train models, extract meaningful features from data, and make accurate predictions. Now, let's dive into some core concepts. First up are vectors, the building blocks of linear algebra. Imagine a vector as an arrow pointing in space. Mathematically, it's a one-dimensional array of numbers. For example, the vector 3, 4 represents a point in 2D space. It's like giving directions to a treasure, 3 steps east and 4 steps north. Next, we have matrices, the powerhouses of data representation. A matrix is a two-dimensional array of numbers like a table. For instance, 1, 2, 3, 4, 5, 6 is a 3x2 matrix. Think of it as a spreadsheet where each cell holds a piece of information. In AI, matrices can represent images, text, or even entire datasets. Now that we understand vectors and matrices, let's explore some basic operations. Addition and subtraction are straightforward. We simply combine or remove elements from vectors or matrices of the same size. Scalar multiplication is like using a magnifying glass. We multiply each element by a number to scale it up or down. The dot product is where things get interesting. It's a way to measure similarity or projection between vectors. Imagine two friends walking in different directions. The dot product tells us how much they're moving in the same direction. In AI, this concept is crucial for understanding relationships in data. Matrix multiplication is the heart of neural network operations. It's like a complex dance where rows and columns intertwine to create new patterns. This operation is what allows machines to process vast amounts of information and learn from it. Now, let's talk about how we can implement these concepts using Python and NumPy, a powerful library for numerical computing. With NumPy, creating vectors and matrices is as simple as using npsysArray. The np.dot function handles dot products and matrix multiplication, while npsysLinealg. Solve helps us solve linear systems. These tools make it easy to experiment with linear algebra concepts and apply them to real-world problems. As we delve deeper into linear algebra, we encounter more advanced concepts. Vector spaces are like playgrounds for vectors, places where they can be added or scaled and still belong. Linear independence is about uniqueness. Vectors are independent if no vector in the set can be written as a combination of others. It's like having a team where each member brings something truly unique to the table. Solving linear systems is another crucial skill. We use matrices to represent and solve equations, either through algebraic methods or code. This is how computers tackle complex problems with multiple variables and constraints. Now, let's connect all of this to AI applications. In neural networks, linear algebra is used for data input and transformation. Each layer of a neural network performs matrix operations to process information. In machine learning algorithms, it's essential for feature representation, helping machines understand the characteristics of data. Linear algebra is fundamental to deep learning. principal component analysis, PCA, image processing, and even recommendation systems. When you scroll through your favorite streaming service and see personalized recommendations, that's linear algebra at work. To summarize, linear algebra is the unsung hero of AI and data science. It's the mathematical language that allows machines to understand and process complex information. By mastering vectors, matrices, and their operations, you're equipping yourself with the tools to innovate in this exciting field. Remember, the journey into linear algebra starts with simple steps. Begin by practicing with vectors and matrices, use tools like Python and NumPy, and gradually build your understanding. As you progress, you'll see how these fundamental concepts come together to create the AI technologies that are changing our world. In our next session, we'll dive deeper into specific applications and solve some real-world problems using linear algebra. Until then, I encourage you to explore, experiment, and most importantly, enjoy the beauty of this mathematical art form. Thank you for your attention, and I look forward to our continued exploration of the mathematical foundations of artificial intelligence.